Well, hello everybody, this is Mr. Kinney. We're going to go over probably the first 12 questions on the acid bases and equilibrium test review here. So, I'm assuming that when you do these problems, you have your notes out, you have your packet out. In fact, I want you to turn your packet to this page and this page because there's information there. So first off, number 1, list the strengths of the solutions in the following pH ranges. Well, I'm not going to do that. You can look on this chart. You can see here's the pH range. We've got a very high pH at 1 and 0, high acidity. We got a very high base level at 13 and 14. You can fill that out. I'm not going to do that. Okay, I will say this is the acid side, this is the base side, and this is neutral. Other than that, you can figure that out. Number 2. Arrhenius, definition of an acid and a base. Well, an acid is defined as forming hydrogen ion in solution, usually water. If a substance forms hydroxide ion in solution, that was the Arrhenius definition of a base. Not all hydrogen ions not all acids form hydrogen ions, so that needed to be modified. And that's where Bronsted-Lowry came along. Bronsted and Lowry, they said an acid will donate / give / supply, okay, can you think of any more? A proton to a chemical. So it's giving away a proton, which is a hydrogen ion. They're the same thing, proton and a hydrogen ion. A base, okay, I ran out of room. Base, well, base is the opposite. Let me zoom in here. A base is going to accept a proton, take a proton, receive, REC, receive a proton, which is the same thing as a hydrogen ion. There you go. What is H3O plus? Well, the name of it is hydronium. It is an acid that forms when a hydrogen ion teams up with a water molecule. Hence you get, I love that, hence you get H3O plus. If you have a plus, acids are always a positive charge. Acids are an electrolyte, which means they will conduct electricity. Acids are always going to be positive. What is OH? Well, OH is hydroxide ion, and that is a base. Okay, I don't think we need to say anything more on that. Number 6, how do you determine the pOH when given the pH? Well, what's nice is pOH plus pH will always equal 14. And that has to do with how much they can exist in solution in at equilibrium with each other. And it turns out that each of them ends up having a hydrogen ion, well, this has a hydrogen ion concentration of 10 to the minus 7. Hydrogen ions, and this will have a concentration of 10 to the minus 7 hydroxide ions, and together in solution you're going to end up with 10 to the minus 14. So 14 in water is kind of a magic number. If you have a pH of solution 5, that means the hydrogen ion concentration is technically 1 times 10 to the minus 5. Okay, so that's the, okay, let me go, the pH of solution 5. Oh, okay. And if this is 10 to the minus 5, the hydroxide ion, I'm not really answering the question, but sorry. These need to add up to 10 to the minus 14. So that'll be 10 to the minus 9. If this is a pH of 5, the pOH has to be 9, because 9 plus 5 should equal 14. 9, 10, 11, 12, 13, 14. Good. pH of 11. Okay, well, if you have a pH of 11, what is the pOH? The pOH has to add up 11 plus X equals 14. So it looks like that's going to have to be pOH of 3. Let me see, did I get that right? If the POH is 3, that means the hydroxide ion concentration is equal to 1 times 10 to the minus 3. So there, take that. The POH of a solution is 5. What is the pH? Okay, really? Okay. 5 plus X equals 14. What is it? Okay, is that 9 now again? Is that right? Because then we have, so the pH this time is going to be 14, where over in this problem the POH was 14. Now you got to always be careful in the questions. Make sure when we ask you something like this, make sure you're paying attention to whether we're giving you hydrogen ion or hydroxide. Because it's real easy to give you this problem and they say, okay, you got a POH of 5, what's the pH? It's real easy to get them mixed up. The POH of a solution is 11. Okay, that's the hydroxide, so we need to subtract this number from 14. And let's see, 14 minus 11, pH is 3. How do you determine the concentration of hydrogen ions when given the pH? Okay, that's where I kind of went over there. So if you're given the pH like we had over here, pH was 5, okay, then the hydrogen ion concentration, let's see, pH equals 5, then this number here becomes the negative exponent for the hydrogen ion concentration. The square brackets mean concentration in moles per liter. So, almost off there. So let's go here. If a pH has a solution of 2, what is the hydrogen ion concentration? That's easy. Hydrogen ion concentration 1 times 10 to the minus. If the pH is 2, minus 2. pH of a solution is 10. What is the hydrogen ion concentration? That's easy. 1 times 10 to the minus. pH is 10. So the hydrogen ion concentration is 10 to the minus 10. I'm just verifying here that they're giving me pH and they're asking for hydrogen ion. Sometimes they could be tricky like this one. The POH of a solution is 2. Let me zoom in here so you can see a little better. The POH of a solution is 2. Okay. What is the hydrogen ion concentration? Now, we're hydrogen ions. This is OH. So the pH would be what? Yeah, come on, you can do it. 14 minus 2. That's right. pH is 12. So now that pH becomes the exponent. 1 times 10 to the minus 12 would be the hydrogen ion concentration. That would be in moles per liter, but chemists are lazy and they just put the square brackets, which means moles per liter. Okay, part D. The POH of the solution is 10. What is the hydrogen ion concentration? Okay, so let's first figure out what the pH is. pH and POH have to add up to 14. So the pH is going to be 4. If the pH is 4, the hydrogen ion concentration is 1 times 10 to the minus 4 moles per liter. There we go. Number 8. How do you determine the concentration of hydroxide ions when given the pH of a solution? That's easy. Okay, so you have to, well, okay, there's a couple ways you can do it. If you've given the pH, okay, find the POH. Once you know the POH, then that POH number becomes the negative exponent up there, times 10 to the minus, whatever that is. So let's practice some of those. You have a pH of 3. Let me zoom in here now. And let's see, if you have a pH of 3, we're looking for the hydroxide ion concentration. We need to find the POH. So let's see, 14 minus 3, I think, is 11, which means we use this as the negative exponent over here, times 10 to the minus 11. pH of 12, okay, the POH, 12 minus 14 is 2. So now that POH becomes, the hydroxide concentration is 1 times 10 to the minus 2. Hey, I got broken glass on group 2. I just, if you could, yeah. Okay, thank you very much. All right, if the POH of a solution is 3, what is the hydrogen, the hydroxide ion concentration? Well, okay, well, we know it's POH, careful, pay attention, that is 3. So now that 3 becomes the negative exponent, 1 times 10 to the minus 3. Let me rewrite that now, 1 times 10 to the minus 3. If the pOH of a solution is 12, now pOH is 12, we're still looking for the hydroxide. Okay, so that's going to be 1 times 10. We take the pOH, and that tells us minus 12. 1 times 10 to minus 12. What is a salt? A salt, well, a couple definitions. It is a metal bonded to a nonmetal, or you can say it is a cation bonded to an anion. Okay, you can also say it's what's formed when acid and base neutralize each other. When acid and base neutralize each other. Neutralize. Did I go off the page here? Let me see. When they neutralize each other. So what is a salt? It is what is formed when acids and bases neutralize each other. You get acid plus base will form water plus salt. And the type of salt can depend upon what the acid and the base was. What is a buffer? A buffer is a solution that resists a change in pH. Resists a change, delta is change in the science world, resists a change in pH. So buffers, they are chemicals, they're going to try to keep the pH the same. What is a buffer made out of? Well, technically it's made out of a weak acid and its conjugate base. What happens is if you dump in, let's say, an acid to this solution, the conjugate base works to neutralize it. If you dump in a base, the weak acid works to neutralize it. You can add, at some point you can overwhelm a buffer and it'll stop working, but our blood system, our bodies are buffered. Our blood system, they try to keep us at a certain pH, and your blood can actually help monitor that to some extent. Let's see, number 11. How do you neutralize an acid? You neutralize an acid by adding base. By adding base. How do you neutralize a base? By adding an acid. Okay, that was tough. Okay, and when you do that, you're going to end up in both of these. When you neutralize an acid or a base, you're going to end up with some water formed and a salt. Water and a salt. S-A-L-T. Okay, and that's where I'm going to end it right here. So long.